Hi everyone, welcome to the Cortex API how-to video on asynchronous function calls. Today, before jumping directly into the code example from the KINOVA GitHub repository, we'll first discuss what exactly are asynchronous function calls. To do this, let's go on the documentation that's also available on the GitHub. So under Cortex, lictmd, cpp API mechanism.markdown, we can see that there are three different mechanisms to call a method using the Cortex API. The first one is the standard blocking method. The second one is the callback function. And finally, there's the async method using futures and promises. The standard blocking method is what we're already used to using when we're doing procedural programming. What this does is whenever you're sending a command to the robot, either a getter or a setter, if you are asking the robot to move or to return a value, then before proceeding to your next instruction, your code will wait for the robot to return a return value. In some cases, sometimes, for example, if you're doing a real-time loop that you want to have a strict control over its frequency, this might be undesirable because you do not know how long some commands may take to return. So to avoid this, you use asynchronous function calls. Those can be implemented either using, as mentioned earlier, callbacks or the async method. The callback method is what we've already implemented as an example for action notification callback in the hands-on session we've done previously on high-level movement. The way callbacks function is you can build an arbitrarily complex method or function and make any kind of instructions inside, and whenever your data is coming back from the robot, if you link this callback whenever you're making your method call, then the callback, as soon as the data is received, will proceed with all these instructions. We can go through the example inside the code later on. On the other hand, when you're using the async method, what you're using is actually a feature of C++11 called futures and promises here. So whenever you're using a future and promise pair, then it means that whenever you're sending your command to the robot, you won't be able to run an arbitrarily complex piece of code whenever you receive your data. However, you can have the method here wait for, and this will tell you whether or not your data has arrived when you come to proceed this instruction. If you hit this and the robot hasn't returned the data you're looking for, then this method will wait for an amount of time up to a maximum of a timeout value that you can set. So why would you use the async method over the callback or vice versa? The main advantage of the callback is that whenever you call it, you can execute an arbitrarily complex piece of code. You can either use standard methods, or you can also declare lambda functions to create your callback on the spot. This means that you can proceed with multiple instructions that will be executed as soon as your data is received. On the other hand, if you do not care about doing anything with your data once you receive it, you just want to make sure you have it, then promises make a more dense option on your code because you do not have to implement a function to call back. It's only waiting for. Additionally, whenever you're using the async method, then you have complete control over the order in which your program is run. When you're using a callback here, suppose you're sending multiple function calls with a callback one after the other. You do not know which one will return first because the first one you're sending might take a lot longer to process inside the robot than the following ones. So you're not sure of the order in which your callbacks will be returned. This may cause errors. Suppose that you're using a variable that's set in one callback inside another if the second callback that requires the variable is called before. and the variable is not available, then you're going to have errors inside your data or even data corruption. To avoid this, if you use your async method, you can wait for all the variables that you need before you execute any kind of piece of code. So whenever comes the time for implementation, you can decide whether you use a callback or an async method or even a blocking method based on this knowledge. Take note, however, that all these mechanisms are specific to C++. If you're using the API with the Python API, then the asynchronous function are not available. You can only use the standard blocking method. This is a limitation of the Python language. Okay, so now that we understand what async methods and callbacks really do, let's proceed with our example. As you can see, contrary to the previous videos, today I'm using a file that's directly available in the KINOVA GitHub repository. So you can go in 00 getting started and use the API mechanism file if you want to follow. So in this file, let's proceed with our main script. So the main script begins with a chunk of code that we're already very familiar with. This is all what's necessary to initialize the API and connect to the robot. Then we have an example for a blocking function call. If you remember what I said earlier, the blocking function call is the method we were already using all along. So this means that whenever you send a method to the robot, before proceeding with your next instructions, your code will wait for the robot to reply with the values that go inside your return value. In this case, for the example, we're using the read all actions from the base client. The read all action takes an action type as a parameter, so we first define an action type. The default value for this action type here is unspecified, so as long as we do not add anything, we will send an unspecified value here, which will allow us to return the list of actually all the actions instead of just a subset of a specific type. So once you call this action, your code will wait for the robot to reply and fill your variable with an action list. Then this action list is sent here to the print action list, which is simply a small function that acts on this variable that we just received from the robot. In this specific case, for the example, the print action list simply goes through all the actions of the list using a for loop and prints all the information that's available on this action. So its name, identifier, type, and the list of permissions that are inside it. So that's it. There's nothing fancy about the blocking method. This is what we're already using and we're very used to. Now let's move on to the callback function call. The callback function call requires you to use your read all action method, but you need to add underscore callback. In addition to this, instead of simply returning as a parameter sending to the robot a requested action type, you also need to send a function callback that's a pointer to a function that you want the robot to run once your value is ready. This function needs to take two things as a parameter. So let's see what's actually inside it. The first thing it needs to take as a parameter is an error. This is in case your method fails and the robot needs to return an error, your method needs to be able to catch it. Then it also returns the action list, which, if you remember in the blocking method, was the original return value for the read all actions from the base. So once you've received this action list, you can do whatever you want with it inside this block of code here, which is your function callback. In this case here, we are printing the action list the same way we did earlier with the blocking method. Instead of using a method that we've already implemented somewhere else, we can inline a method using lambda functions. So you can implement lambda functions using this syntax here. So you can call auto given name to your function and use the empty bracket identifier to tell the compiler that you're about to declare a lambda function. These are the parameters that you want your lambda function to take, and this is what you're doing whenever you want this callback to be run. So again, if you call read all actions underscore callback, but instead of sending the pointer to your original function that you implemented elsewhere, you can send the variable of your lambda function as a parameter, and this will run instead. And that's it for callback functions. Now let's take a look at the future function and async method. Again, the async method for read all actions still takes a requested action type that is still undefined and nothing else. However, note that there is still underscore async here. This is to tell the robot that the return value you want is not actually an action list, it's actually a future action list. Future is a keyword that's available for C++ 11 and onwards. So the robot will return a future value. Then we can decide of a maximum time we're willing to wait for this value for the robot to send it back. In this case, we're choosing 10,000 milliseconds, so 10 seconds. And we're setting here, we're using a future status to see if our variable is ready or not. So we will be waiting for our variable up to 10 seconds. So either two things will happen. Either 10 seconds will pass and our status will not be ready, in which case we will throw an error, or the robot will return this and we will immediately exit this and proceed with the next instructions. However, as I mentioned earlier, the return function for read all actions async, the return variable is not an action list, it's a future action list. So if you wish to have access to the actual action list, then you need to take your future action list and use the get method to have access to the actual object. And then once you have it, you can proceed to do whatever you want with it. In this case, we are still printing our action list using this method again. All right, so let's conclude with our example router options. The example router options is a case where we want to change the default behavior of the blocking method. I said earlier that the blocking method would wait for the robot to return your return value for as long as it takes before proceeding to the next instruction. That was not 100% true. The robot has a timeout value after which, if the value is not available, it will throw an error for a timeout. By default, this timeout is 10,000 milliseconds. If you wish to change this value, for example, to increase or lower it, then you can create router options using router client send options, and then change the field called timeout milliseconds to whatever value you're interested in. Here we're taking 5,000 milliseconds. You will see that router options also contain additional fields named endForget and delay milliseconds. Those are currently unused but will be released in a future release to be able to use send and forget methods with the API. So once you've created your router options, you can send them to the robot at the same time as you're sending your regular action with the same function call. So we were using the base client read all actions, and instead of adding only the default parameter, the default that was required, then we want to add our custom value of router options, which was an optional parameter earlier. Because this is not this is the last parameter, we also have to define device ID. In this specific case, we're sending our action to the base, so we set the device ID to 0, and finally our router options. So let's see how this all behaves. As you can see, we've printed the information for all the actions of our lists many times over. So we did it once for the blocking function call, then once with our function callback, once with our lambda function callback, once with our future, and once by changing the default router options. And everything went well. So that's it for example today. Contrary to the last few tutorial videos, this video will not be followed by a hands-on session. If you remember, in our last hands-on session, we already implemented the action notification callback, so we can reuse the piece of code that we already had, and we already covered the the theory that we learned today. So stay with us, join us for the next videos where we will learn how to use low-level API commands to be able to access the cyclic mode that refreshes at 1 kHz. Have a good day and thank you for watching.